Group is the energy storage team. You have batteries and then other alternatives. Give me the highlights for energy storage and then the possible different routes that you can go, because I know we've talked about this.
So let's first talk about battery storage. You know, if you go look around the world today, the most common, the simplest, and the easiest thing is to store electricity in a battery, right? I mean, every consumer electronic device you have stores in a battery. So that's where we're going to start, okay? And the batteries team's first job is to pick a battery supplier with the technology in the battery that sort of meets a low-cost requirement, but also has the ability to cycle enough times that you can run the system without a degradation of any appreciable amount for at least the first 3 years, you know, and we're hoping to get at least 5 years and maybe longer, because that's the problem with batteries, is that over time, because of the chemistry in them, they fail. Okay. So, but the first team, you know, for that battery team, we need to launch with batteries. It's clearly the way to start, and so that team needs to help us on the battery selection.
You launch with batteries, but that's not the ideal solution.
It's not the ideal solution. There are technologies being developed on the battery side that would give you a 20-year cycle life for batteries. Okay? They're coming. It's not so clear when they arrive and if they arrive at the right cost target. But there are companies working on it today. Some of them are flow batteries. Some of them have different chemistries than we're used to seeing, but you know, they're not ready today. So I think that the way to think about this is Light the World launches with more traditional batteries because that's the storage that works. And simultaneously, Light the World launches 2 additional efforts. One effort is to try to look at all the different batteries that are coming along to see if any of them better fit the requirements for the microgrids and the mini-grids. The other approach is what we've put into the Collegiate Challenge, is to find a non-battery solution to energy storage. And in the Collegiate Challenge, you know, we'd like to go ask mechanical engineers and physicists and physics majors to go and look at all the different mechanical solutions you might find to provide the amount of energy storage that we need. Because if we could find a mechanical solution, we would have a long life solution that doesn't degrade over time.
The next team is power regulation and conversion.
Yes. So this is a very important team, and it's turning out to be a hard one to recruit for, maybe because we're not looking in the right places. But this team actually is responsible for the DC microgrid controller and the DC mini-grid controller. So this is the team that actually will build the brains behind the microgrids and the equipment to convert the power, to manage the power inside of the microgrid. Okay? There we need all kinds of help. We need electronics people, electrical people, board layout people, you know, mechanical designers, people who work on aesthetics. I mean, it's a really big effort that takes a lot of skills to put together this particular part of the solution. Okay? And I would tell you that anybody who has an inclination on the technical side or the mechanical side or the design side can help us on the microgrid controller teams.
The next team is